Our team worked visualizing the airplane crashes. We used multiple technologies to make this visualization possible. We use Python based Flash framework as a backend. We use multiple JavaScript visualization libraries for the visualization, such as D3 HiChart, D3 GeoMap, data maps. We also used other APIs for converting the location into the spatial format in which we wanted. We used Google Geocoding API as well as the GeoNames API so that we could get the ISO Alpha 3 country codes, which is actually used by the Choropleth for plotting. We also use Bootstrap for styling the front end visualization, and we use jQuery and jQuery UI to add interactive to the visualization. So our first task was basically finding out the number of survivors against the flight type. Our dataset actually did not contain the capacity of the flights. It instead contained the aircraft type, and which was basically the brand name followed by the type of aircraft it is. And it was not very intuitive to basically figure out which kind of aircraft had lesser number of fatalities. So we thought we'll do it against the brand name. So we did a bar chart representing the categorical information, which is the brand name along the x-axis, and the number of survivors along the y-axis. This is the aggregate taken from 1908 to 2016. So what you can do is you can select the number of survivors range, and based on that the bar chart is populated in real time. For this we're using D3v4 version, and we realized it actually does not answer the question what it's supposed to do. So then we thought, why not use a box plot? So we went ahead building a box plot. This shows for the five most famous brand names for which the data exists. And what we try to show here is the maximum, minimum, the upper quartile, median, and the lower quartile. So we thought doing a box plot would actually give more insights, but it actually did not. So I think it's one of the limitations of the data set, that we can go only so far with the limited data set that we have. The next thing that we did was small multiple. This is how we started doing. So this is basically to correlate the accidents between two tickets. So when you go over any of the point, you basically get the number of fatalities in that area, and you also get a summary of why the accident happened and information such as uh, what is provided in the data set. So this is how we initially thought of doing small multiple. The blue ones basically uh, represents the regions or points where the number of fatalities were less than 10, and the red ones represents regions where the fatalities was greater than 10. Initially we designed small multiple in this way, and then based on some feedback we realized it was kind of necessary that when you have small multiple, if a particular region is selected, if you zoom in, it would give more visibility and more understanding to the user. So that is exactly what we did. So when you go into and select a particular map, it expands, and then you can see a larger view of it. And here you can select on a particular point, and then it gives the name of the operator, and then the location where the action took place, and the number of fatalities. The color coding scheme is similar to the one that was used before. It's basically uh, we get the threshold value of 10, which is the kind of the average that we got when we saw over the all the actions that have taken place in 1908. So the other thing is what happens if you go to a small multiple plot which is below. So you can't scroll your screen upwards to go and see the zoomed in version. So what we did is we made sure that that part gets zoomed out, and then we add a new element in here, and then we are able to zoom in and do something similar. So one thing to be noted is if you see from 2010 to 2020, which is actually the data from 2010 to 2016, you can see that the number of accidents is more as expected in US because of more number of flights and stuff. But you can see that the number of fatalities are usually less than 10. So this could mean a number of things, but I think it's a good insight to see that although the number of accidents have been more, the number of fatalities are actually pretty less. So next, let's see choropleth. So what we did choropleth was to find the number of accidents for a particular year. So you can select a particular year using the range, or you can select a particular year by selecting the drop-down option, and then it populates for that particular year. Based on some feedback, we thought it would be more useful to have it cumulative. So from 1908 to that particular year. Uh, One thing to be noted is when we do these stuff, uh, like you can't clearly differentiate between regions, uh, uh, because the upper limit, or which basically represents the number of accidents, uh, the y-axis. Okay. Now let's look at choropleth. So here what we are trying to do is we are using spatial dimension and then trying to figure out which region has had more number of actants and which region has had lesser number of actants. So you select a particular year using the range, or by using the drop down option. You get to know where the actions have happened more frequently and where the actions have happened less frequently. So but the objective was to find out over a period of time. So one thing we came up next was to do it cumulative. So if I go to a particular in 1961, it is from 1908 to 1961. As you can see, this dark greenish area, the remaining places all show like as if it's zero, which is actually not the case. This is happening because the regions in the US have had more number of accidents compared to the other regions. So then what we decided was, uh, instead of doing something like this, it would be better if we are able to show it in logarithmic scale, and that is exactly what we did next. So you go to using the logarithmic scale, this makes more sense. Now you can see that US still has more number of accidents, but other regions do have some accidents as well. uh, and when you select a particular region, it shows the number of accidents in that particular region, and so on and so forth. uh, the next thing is what we did is, instead of selecting cumulative, let's select between a range of period, between a range or a period of time. So why this is advantageous is because it makes more sense to see actions happening in the last 10 years, last 20 years, or between a period of time, and then trying to analyze like what went wrong or what went correct during that instant of time. The other thing that we designed was stack load. So here you can select a particular year and then it gives you information with respect to the summary for that particular year. So this information is actually obtained from the summary field that is present in our data set, and we find out the top 50 words after removing the stop words, and then just plot it around so that you can make some kind of insights on why the action took place. Example, if I go to a particular year 1961, you can see that uh, during landing is one of the words, so it's probably like during the landing more number of actions actually took place. You can see the word exploded here. You can see the word mountain here. So here you can see even the word weather. So these are the words which actually indicate like why the accident actually took place, which is part of summary. So we thought it's a useful visualization to have. Now let's look into linked views. So in linked views, what we try to do is basically integrate the choropleth with the tag cloud, and based on some feedback, we tried doing exactly the same thing that we had done for choropleth of having the range, and we even did the range part for the tag cloud. And then you could optionally select logarithmic scale or the linear scale, and then yeah, to make the linked view even more useful, what we decided to do is we will add a pie chart which shows the number of percentage of number of survivors and the fatalities. Why this is useful is we could kind of figure out, although like when accidents happen, is it like everyone die, or is it like there are more number of survivors? Is there any trend observed? Like, are more people surviving during aeroplane crashes in the recent years, or some stuff like that can be actually uh, extracted from this. So as you can see here, the survivors is 27% from 1962 to 1989, and it is 31% between 1976 and 1989. So that is one more useful thing that we try to add to the linked view. And the calendar heat map is the next visualization that we try to do. So this is a visualization which is really unique in the sense there is this field called as ground fatalities. So what that means is these are the number of people who have died on the ground when an aeroplane has crashed. So it's not the people who are on board the flight, but it's rather the people who have died because of the aeroplane crash. So one thing that you can note for sure is if you go to 2001, which is here, if I go to the ninth month, and if I go to the day 11, you can see that the ground casualty is 5,625. This is the 9/11 that actually took place. So this is a unique visualization. Although it's too sparse, it can actually indicate which aircrafts actually uh, crashed into a land area or a populated area or something like that. The another visualization we had done is the calendar heat map cumulative. So what this is basically to indicate on which particular day of a particular year we are seeing more number of accidents. So in 1920s, you can see that more number of accidents were actually happening on a Monday, whereas in 2000 you can see that more number of accidents were actually happening on a Friday. So this is basically a heat map which gives you information regarding when the accidents are happening.